Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which finds the number of ways to traverse an n-ary tree. First, let us take an example. We have to find the number of ways of traversing the whole tree starting from the root vertex. There can be many ways. The count of all ways to traverse is the product of factorials of the number of children of each node. Node A has 4 children, so 4 factorial permutations are possible. B has 2 children, so 2 factorial permutations are possible, and so on. Hence, we multiply all permutations and get the final result. Now, let us have a look at the algorithm. Let us also take a sample tree to test our algorithm. In this tree, node A has 4 children, node B has 2 children, node F has no children, and node D has 1 child, and node E has 3 children. We pass the root node, which is A, to function calculate ways. We initialize a variable ways to 1. As root is not null, we create a queue and enqueue the root into it. So, A is pushed into the queue. Now, as queue is not empty, we do a level order traversal of the queue. So, we take a node P and it will point to the front element of the queue and dequeue an element from the queue. So, P will point to A and A will be dequeued. Now, we find the number of ways, which is the product of factorial of number of children of each node. We are assuming that the function to compute factorial of a number is already there, which returns the factorial. So, node A has 4 children and hence the factorial function will return 24, which is 4 factorial. We update ways to ways into factorial 4. So, ways will be equal to 24. Next, we enqueue all children of the dequeued item. So, all children of node A, which are B, F, D and E, will be enqueued one by one. As the queue is not empty, we continue with the while loop. Now, P will point to B and B will be dequeued. Again, we call the factorial function with the number of children of node B passed as parameter. As node B has 2 children, factorial 2 is 2 and hence we update ways to ways into 2. Now, we will enqueue all children of node B. So, K and J will be enqueued. Again, as Q is not empty, we continue with the while loop. Now, P will point to F and F will be dequeued. As node F does not have any children, the value returned by factorial function will be 1 as 0 factorial is 1. Hence, ways remain same and nothing is enqueued. As the queue is not empty, we continue with the while loop and now P will point to D and D will be dequeued. As D has only one child, the factorial function will return 1 and ways will remain as it is. Next, we push the child of D, which is node G, into the queue. As the queue is not empty, we continue with the while loop and now P will point to E and E will be dequeued. As node E has 3 children, we calculate 3 factorial and update ways to ways into 3 factorial. So now ways will be equal to 48 into 6, which is 288. Next, we enqueue the children of node E. So C, H and I will be enqueued. As the queue is not empty, we continue with the while loop and now P will point to K and K will be dequeued. As node K does not have any child, 0 factorial will return 1 and hence ways will remain same. Also, nothing will be enqueued into the queue. We continue with the while loop. Now P will point to J and J will be dequeued. Again, as node J is a leaf node, ways remain as it is and nothing will be enqueued. We continue with the while loop and now P will point to G and G will be dequeued. G is also a leaf node, so variable ways remain same and nothing is enqueued. Next, P will point to C and C will be dequeued. C also doesn't have any childs, hence nothing is enqueued into the queue. We continue with the while loop and now P will point to H and H will be dequeued. H is a leaf node, so we continue with the while loop. Now P points to I and I will be dequeued. Node I is also a leaf node and hence ways remain as it is and nothing is enqueued. As the queue becomes empty, we come out of the while loop and return ways, which is 288. And that is the number of ways to traverse this tree. Now let us have a look at the time complexity of the program. We visit each node once during the level order traversal and take big O of n time to compute factorial for every node. Total time taken will be big O of capital N into small n, where capital N is equal to the number of nodes in the n-array tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.